Hello, everyone, and welcome to our Wet Space Senior Design sponsor meeting. I'm Caleb Marcoux, the product manager for our Wet Space team.
And I'm Chase Pearson, the development manager and squad lead.
Our project was sponsored by Massimiliano Pierobon, who is with the MBiTe Lab, which stands for Molecular and Biochemical Telecommunications. And they perform research on molecular and biochemical networks. Our project proposal was to create a web application that's kind of this hub for communication between existing platforms for doing these biological simulations. And it allows users to combine the results from these different platforms into one centralized application. Our stakeholders were our sponsor, Massimiliano Pierobon, and his students also that are doing research, Tyler, Bo, and Kartik, as well as our development team, which is Chase Pearson, as mentioned, and he was the squad lead as well as the primary backend developer. Myself, Caleb Marcoux, I was the product manager and primary UI developer. Gerson Uriarte, who was the primary developer for the database. Ying Sung, who was the secondary UI developer, and Zoe Hudson, who was also a UI developer. Our tribe lead was Vinod Viriyama, and our project manager was Melanie Kugler-Wright.
So I'll talk a little bit more about the background of our project. As Caleb mentioned, the MBiTe Lab does research in molecular communications, primarily on the application of communication and information theory to chemical reactions, molecule exchange, and transport processes. Now, they have a lot of goals of their research, but two of the primary goals are to accurately model and analyze communication in wet or living systems, as well as to enable the future engineering of biological network applications. So a couple examples of this are engineering in synthetic biology, engineering in nanotechnology, and biochemical engineering. So what was the problem that we faced and the solution that we developed? Well, two of those simulation platforms that Caleb mentioned are Wetcode and Paradox, and they're currently hosted on separate pages and have separate usage and output. So in their current state, a user has to set up a simulation from scratch every time they visit one of these pages to use that respective simulation platform. Now, the aim of our project was to create a single hub where our sponsor or another researcher can use these simulation platforms in that central location. So because of this, the output from Wetcode can be used as input to the next simulation, Paradox, creating a pipeline or track of simulations. Now, we also allow users to create accounts so that their simulations and data persist between sessions. Now, we had both some functional and non-functional requirements of our project. On the functional requirements, we needed a user account system. So this includes the ability to create accounts, log in and log out securely, persist data between sessions, and provide user authentication. We also needed to create a GUI allowing interaction with external or third-party simulation platforms. So this includes passing data as input to these platforms via their APIs, as well as graphically displaying the simulation results. Now, our non-functional requirements included modularity and extensibility so that in the future, additional simulation platforms can be plugged into the system, usability for the end users, as well as fault tolerance for when simulations have errors so that the system can handle those errors gracefully.
The solution that we built is called Wet Space, which is a cybernetic platform for wet information systems space analysis. And it consists primarily of these cards that you can see here, which represent a simulation pipeline with the biological channel on top, you can see represented by the blue section, and the molecular to electrical interface on the bottom represented by the yellow section, and data will be passed through this pipeline. On our main page, we have a quick description and links to a tutorial where you can get more information, and our login page. You can log into your account by entering your credentials and pressing login, and you will be taken to the dashboard where a user can see all of their previous simulation cards here, as well as create a new simulation. If you would like to see a full demo, you can stop by our booth.
Now I'll go into some of the technical details and implementation of our project. We'll start by looking at a high-level architecture of WetSpace. We have a 3-tiered architecture, so it's split up into the front end, the back end, and our database. On the front end, we have our GUI that you just saw, as well as a data processing module and an API controller to handle communication with our back end. On the back end, we have an API that was implemented in Java, as well as a set of libraries for communicating with external systems like Wetcode, Paradox, and in the future, other third-party systems like KBase or OSI. We also have a database interface, which allows us to interact with our database using an abstraction layer. So the dashboard, as you saw, houses the user simulations and allows data input and display. We decided to use React to create this front end so that our GUI is responsive. Now, our front end also sends requests to our Java API, receives the responses as JSON from that API, and is able to dynamically update the view with new data. Our API is deployed on Apache Tomcat and uses the JavaX Servlet 3 library. It is responsible for handling incoming requests from both our client as well as external clients, providing security and authentication using JSON Web Tokens, performing logging of security events, and gracefully handling failures when they occur. Our libraries component supplies the API with additional abstract functionality for completing background tasks. This includes things like low-level HTTP requests and responses, an email manager, configuration parsing, and drivers for communicating with external simulations. Finally, we have the database access layer, which abstracts the persistent data from the API so the API never directly interacts with our database. It provides a clear interface for storing and retrieving persistent user data and implements a light object relational mapping-like functionality, which provides the API with data in the format of a Java class. Finally, the database access layer provides another level of graceful failure handling.
Our system provides several highlighted value points for the researchers. Primarily, that is that they can use a single workflow on our platform to access both Wetcode, Paradox, and future systems, which also transfers their data between those systems so that that's easier to do. It also provides user accounts for those users so that they can get benefits like this persistent data, that they can see their previous simulations that they've run easily in one place. It also provides expandability for future platforms and systems that may be useful in the future but are not yet created.
That's all that we have for you. Thank you everybody for attending our presentation, and don't forget to stop by our virtual booth to see a full demonstration of our system. We have a couple more minutes left, so if anybody has any questions, we can take them now. All right, if there are no questions, then thank you again for coming.
Yeah, let's give a thank you, a virtual thank you to our presenters, either through the clap emote or just typing it out in chat.
Thank you.
Just saw Hunter.